Hello, everyone. We are Group 22, Taqueria Electrica. Our project is the ROMET TE Electronic Larynx. I am Jamal Khan, and my group members are Manuel McKinley and Justin De La Vigna. So a little bit about us. I am a senior electrical engineering student with a concentration in electronic materials and devices. And for this project, I was a project manager, as well as the one responsible for all the hardware and software related to the power delivery of the device.
How are you guys doing? I'm Justin De La Vigna, and I'm also a senior electrical engineer. I was responsible for developing the app and also the documentation lead for our project. That just means I was responsible for documenting any minor and major changes to the project to help aid into finalizing the document that goes over all the details and specifications of our device.
Hi, my name is Manuel McKinley. I am a senior computer engineering major. I was the Bluetooth and PCB lead for this project. My responsibilities included all the hardware and software components related to the Bluetooth and motor, while also designing the PCB. Our sponsor for this project was ROMET. They were founded in 1979. The current president is Tom Dotson. Our technical advisor for this design project was Nico Gallardo. ROMET offers a wide range of electronic larynx devices and stoma accessories.
So what is an electronic larynx? This device is intended to be used by those who had their larynx removed in a total laryngectomy surgery. Instead of breathing through the mouth and nose, a hole is placed in front of the neck, which is referred to as the stoma, and will act as the source from where oxygen will flow from. The air traveling from a person's lung is what drives the sound of the voice, while the larynx, more specifically the inner flaps of it, form different shapes to change how the vibrations will pass through the throat, thus altering how the voice is perceived. The patient's mouth and nose will now be connected to the esophagus, which will lead directly to the stomach. To help resolve this, an electrolarynx will be used to act as the driver and vibrational apparatus to produce sounds. By using a vibrating electrical mechanical striker to hit against the head of the device, placing it against the neck, and changing the shape of the lips will allow the patient to be able to produce comprehensible words for others to understand.
So for this project, we decided that our primary goal was to update the electronics of the device to give it more user functions and make it more interactive via smartphone application, while also maintaining the original electromechanical striker motor. In order to accomplish this, we designed a custom PCB with integrated Bluetooth functions. We installed a new battery with a charging module for easy charging, and we developed an Android application to control the device's functions and read device data over Bluetooth.
For our Bluetooth module, we decided to use this so that we can connect via a smartphone. Our Bluetooth module also enables communication between devices so that we can control motor activation, pitch, volume control, and display the battery data. For our hardware, we decided to use an ESP32, two different type MOSFETs, various resistors and capacitors, and a push button.
Now, in order to make the device rechargeable without removing the internal battery every time, we replaced the 9-volt battery with a 3.7-volt LiPo battery. This battery is connected to an Adafruit 4410 charging module, which uses a standard USB-C cable for charging. And with this module, the ESP32 is able to read the battery level percentage and charging status. However, in order to power the ESP32 and drive the motor, we also need to connect it to a voltage regulator. For our breadboard development, we went with the Adafruit 4654 voltage regulator, but for our PCB design, we switched it to an LT1763 regulator, which allows it to output a constant 3.3 volts regardless of the input voltage.
When designing our PCB board, we used Eagle. We used the ZXM MOSFET for our final design. The reason why we chose this MOSFET was due to the fact that it has a low threshold voltage, low on resistance, and fast switching speeds. As you can see at the bottom of our page, we have our PCB designed in Eagle, and then to the right of that, we have our physical PCB with components. When designing our casing, we decided to use Fusion 360, and when we finished with this design, we sandwiched that in between the motor and handle. To the right of this, you can see the physical casing that is going to be put in between our product.
So for the phone application, it was developed using Android Studio and written and compiled in Java code. Through research, we found that most laryngectomies are going to be in the older age range where a sense of sight and touch are not going to be as strong as they were when they were younger. Therefore, we created an application that will have large, identifiable buttons to make it simpler for the user to see, such as the ones that can be seen in Figure 1. And we also created a display for the way of information to be shown by using large and bold text to make it easier for the patient to be updated on the device's battery status, what the pitch is currently at, and how low the volume is.
So here's a video showing the prototype in action using our breadboard prototype. Here we have our group poster, which describes the project at hand, including the introduction, the current needs of the device, the approach we took, all related diagrams that we developed, what the final product looked like, and our conclusion in the end. And there you have it. That is the ROMET TE Electronic Larynx developed by us at Taqueria Electrica. And before we wrap things up, we just want to give a few acknowledgements to Tom Dodson and Nico Gallardo at ROMET, as well as Dr. Patrick Benavides for giving us a lot of technical guidance throughout the realm of this project. Thank you very much. Do you have any questions?